Welcome to the APD Awards Show, everybody. I'm your host, Michael Asanti. Let me introduce to you our nominees for today. First, we have Miguel, who is easily the most talkative person during the meetings, always has something to say, can never reserve himself, can never be quiet, always wants to say something. Then we have Ermine, who's actually the quietest person on the team, never has anything to contribute, is really lazy, doesn't ever want to do anything for the project. Then we have Esmita, who is probably the meanest person I know. In fact, for our one-on-one, she brought me chocolate. Like, who does that? But we also have Wendy, who falls asleep approximately 30 times each meeting, in about 1 minute increments each time. And last but not least, we have Alyssa, who is probably the only one I know that actually likes the state of Kansas. So none of that is serious, by the way. So with all jokes aside, I've seriously enjoyed working with this team. It's easily been my favorite semester of my college career, and all of that is to do with this team because they're just such great people and just probably the smartest and most gifted and intelligent people I've ever gotten to work with. And we've just made so much progress this semester, and I'm just so excited for you guys to see what we have. So without further ado, I'd like to introduce to you Team StarGait.
Hello, everyone. So, in 2014, the economic burden of people diagnosed with Parkinson's disease was $14.4 billion in the United States. In 2017, this number rose to $51.9 billion. However, Parkinson's disease is much more than financial and economic limitations. Imagine living in a world where attending a baseball game or going to the grocery store is nothing but a challenge. 50% of individuals who are diagnosed with Parkinson's disease experience episodes of freeze and gait, which is a symptom that hinders movement due to the user's inability to receive signals from the brain, thus causing the motor system to freeze for seconds or even minutes. That is why Dr. Wong, our inventor, has tasked us to create a human-centered device that is accessible and easy to use. After conducting over 30 interviews and with the help of Dr. Wong, our inventor, we've developed a prototype for a device that straps onto the ankles, detects when an episode of freeze and gait is occurring, and provides some sort of haptic, otherwise known as vibrational tactile feedback, to reinitiate movement. We've developed the business model to help structure the commercialization of this product and a financial model to understand the financial implications of this device. My name is Miguel Payana. I'm a current sophomore studying architectural engineering.
My name is Alyssa Campbell. I'm a current senior studying biomedical engineering.
I am Asmita Barua, a senior in chemical engineering.
I'm Wendy Hahn, a senior in economics and international studies.
My name is Ermin Kevric, and I'm a senior studying electrical engineering.
And we're Team Haptic Feedback. Before we could really start designing our prototype, we had to ensure we had a better understanding of the impact of freeze and gait and the major problems associated with it. This included a list of personal setbacks that revolve around the end user and technological limitations that exist with the current solutions that are on the market right now. Since the demographics of individuals with Parkinson's disease are over the age of 65, they are more prone to falls. This makes their annual freeze and gait related treatment an annual cost of $10,600. This includes the purchasing of strong medical devices, prescribed medicine, or physical therapy, and doctor appointments. In addition, Parkinson's disease individuals are rendered dependent and require some sort of assistance from caregivers to complete daily tasks. And lastly, in an interview with Connie, who is an individual with Parkinson's disease, we found out that the stigma behind Parkinson's disease is much worse than we thought. A couple steps before stepping onto an escalator at a baseball game, Connie experiences an episode of freeze and gait, which leaves her frozen. However, all she could think of at that moment were the remarks of the people around her that revolved around, why is this woman just standing here? Why can't she move? However, there are also technological limitations with the current products that are on the market right now. These current solutions impede mobility and are too complicated to use. As mentioned previously, Parkinson's disease is an already expensive disease, and these solutions will incur more costs to the already expensive disease. And lastly, these current existing technologies don't offer data collection information systems that are accessible to the end user so that they could further develop the reasoning behind their episodes of freezing of gait. Now that we've addressed the issues of freezing of gait and the impact of Parkinson's disease, we'll be delving deeper into the solutions we've developed to counter these problems.
To better understand how we can solve these problems for Parkinson patients, we conducted over 30 interviews with patients and their support groups. In those, we identified user needs that we needed to implement in our solution. It started with the price. We found that Parkinson patients are encouraged large costs due to their medical condition, and we didn't want to add on to that. So we set our price at an affordable $500 so that it could be accessible to all patients. Additionally, in 80% of interviews with patients and their supports, which include physical therapists, caretakers, and doctors, we found that they all wanted a device that could collect data. That way, the patient can understand the progression of their disease and what episodes look like for them during the day. We also conducted many patient interviews and found in 70% of them that patients want a device that is easy to use. In an interview with physical therapist Dr. Miller, we found that many patients have personal hacks to get over the episodes. One of her patients had her husband throw a piece of paper on the ground so that she could imagine stepping over it to reinitiate her gait. We know that these personal hacks exist and they're easy to use and affordable, so our device needs to mirror that so it's easily implemented into the patient's life. And finally, with easy to use, our device cannot interfere with the already worsening gait condition, so it needs to be lightweight at around 250 to 300 grams. That's when we started the iterative process to get a prototype that can solve these problems. It started with the pressure gauge handles, which was a device connected to the walking assistive device in the patient's life and would measure the dependency that the patient had on the walking assistive device. However, we found with many interviews with physical therapists that this device would not work because advances in medication are phasing out walking assistive devices in the Parkinson population. So then it moved to the hip accelerometer, which was an accelerometer that would track the tremor in the hip that occurs when a freezing of gait episode is happening. While the accelerometer is able to detect that tremor, the hip was not the most sensitive location. And that's when Terry Chow, the CEO of StepWatch, another device that does real-time gait analysis in clinical settings, suggested that we use the foot as the location, as it is the most effective and precise measuring location for the tremor that happens in a freezing of gait episode. With all of these solutions in mind, we came up with our product, StarGait, which is friendly in its technical effectiveness and its ergonomic design. As Asmita is showing here, this is what the patient will go to grab when they start their day with StarGait. They will grab a device that is slim in design and lightweight thanks to its TPU material. They will also apply the design to both of their ankles using an adjustable strap that is made of silicone so that it is not harsh during the daily wear of the device. They will then go about their day, running errands and being independent, when the accelerometer will detect the freezing of gait episode. The discrepancy in the gait, that tremor that happens when the gait episode is happening, will be detected, and the vibration motor will cue off vibration to both ankles, no matter where the tremor happened. These two components are interfaced by a microprocessor called an Arduino board, which is pictured to the right of the CAD model. Then the details about this episode will be collected on the device and uploaded to an interface so that the patient can understand what their day looked like in terms of their episodes, how long they lasted, and how severe they were. This can help with changing medication techniques and physical therapy techniques so that the patient can best reduce the severity of their episodes. And finally, they will go home and plug their device in and recharge the battery so that they can have another long day using StarGait. Now, this is what the daily use of StarGait looks like. Let's understand what the electronics are doing on the inside so that they can track a freezing of gait episode.
So StarGait will use a three-step process to determine when a freezing of gait episode is taking place. The device will consist of an IMU, which is an inertial measurement unit, and an accelerometer. The IMU will constantly collect data, while the accelerometer will be used to check changes in gait. The process will begin with its initial state. During this time, the accelerometer will be turned on and will be checked whether changes in acceleration takes place. When the acceleration drops below a certain threshold value or the changes in discrepancy are very large, a signal will be sent to the state 2. During this state, it will be determined if the changes in acceleration take place for a prolonged period of time. Once again, if this is true, a signal will be sent to the third stage, which is the red flag. During this time, the activation will begin and the vibration motor will begin to provide haptic feedback. From multiple interviews conducted with physical therapists, it was validated that vibration provided at randomized frequency will be the most effective way to provide any type of feedback. Once the person begins to go back to its initial gait and have a restored normal walking pattern, the program will begin to go back to its initial state, where once again, the device will begin to collect data and the accelerometer will be turned on. The video demonstration here depicts the changes in acceleration. The larger change in oscillations depict when an end user is walking with its normal gait, versus the significantly smaller changes in oscillation which detect when a freezing of gait episode is taking place. This is the time when the vibration motor will be activated. Although StarGait is a very viable option, there are multiple other competitors in the market. Two of the most common ones include LaserCane, U-Step2, and Pathfinder. These are visual feedback devices, and although they are able to reduce the length of an episode, they're not very easy to use. These devices are either attachable to your walker or cane or wearable devices. When an end user detects a freezing of gait episode is taking place, the person will need to bend down, press a button in order for the visual feedback to be implemented. This impedes their mobility and therefore it's not the best recommended use. These devices cost at around $250 to $450 approximately. Our next two devices provide haptic feedback. They're able to reduce the length of an episode and or also provide discrete feedback due to the haptic feedback, which is the vibration. However, after being able to speak with the sales representatives, it was determined that these are one of the most expensive devices in the market, ranging at around $3,000 per pair. All of the devices mentioned above either do not have any data collection capability or is very limited. This makes StarGait a very competitive device. And due to this, it is also important to understand how StarGait will be marketed to the target market and how this will be done.
StarGait has the opportunity to impact 3 million people in a total annual domestic market of $166 million. Our end user population includes people diagnosed with Parkinson's disease and other neuropathy disorders. This population is growing with 60,000 people diagnosed each year, 50,000 of which with Parkinson's disease. There are currently 1 million people living with Parkinson's disease in the US, with a third of them frequently experiencing episodes of freezing of gait. Parkinson patients spend about $10.6 thousand per year on freezing of gait-related treatment, ranging from doctor and physical therapy appointments to purchases of prescription medication and durable medical equipment. Late-stage Parkinson patients, stages 3 through 5, experience the most freezing of gait, and it is these end users that the team hopes to reach with StarGait, our user-centered device. The team has segmented our end user population into two groups, Type 1 and Type 2, after conducting over 30 interviews and surveys with end users and verifying our research with multiple interviews with medical professionals. Type 1 end users experience less frequent freezing of gait, only multiple times per week. However, they will have an increasing need for use of StarGait. Type 2 end users, on the other hand, experience severe freezing of gait with multiple episodes per day. And in addition, 60% of Type 2 end users stated that they require daily assistance from caregivers. These two types of end users will receive StarGait after StarGait goes to market in a multi-year phased approach. First, OU's Office of Technology and Development, or OTD, will hire a medical device design firm, Device Lab, in order to complete research and development. Device Lab will help StarGait become certified as a Class 2 FDA medical product and will help StarGait become reimbursed by CMA Medicare insurance. OTD will also file a provisional and utility patent on StarGait and license StarGait to a party for $10,000 exclusive licensing with 2 to 5% royalties on revenue. The contract manufacturer will receive $10,000 to $100,000 from the license holder of StarGait in order to begin producing StarGait at $100 per unit, with a unit being 2 devices, 1 for each leg, at a total markup of 400%. Type 1 end users will buy StarGait from Walmart or other medical equipment stores for $500, with distributors taking 15% of the revenue. Type 2 end users will be prescribed StarGait after talking with their medical provider or other physician with insurance helping to reimburse part of that cost because these end users experience severe freezing symptoms and need the use of StarGait. No matter how StarGait is distributed, it is also important to understand the financial implications of the device.
Due to StarGait's competitive price and the demand of the market to treat freezing of gait, the team has calculated that StarGait will result in $1.7 million in revenue over the next 5 years. During first 2 to 3 years, StarGait will not be profitable, as in this time frame it will incur costs due to research and development, due to the costs associated with filing for provisional patent and utility patent, FDA certification, and clinical trials. Only after these have been successfully completed will StarGait start turning a profit. The profit calculation was based on the assumption of initial buyers and the projected market growth. The number of initial buyers was assumed to be 1,000 people, which represents a fraction of population of Parkinson's disease people, which stands at 9,000 people that live in Oklahoma, reflecting official Medicare records. As the team projects that the market will grow at 1.05%, which reflects annual incidence of Parkinson's disease in the United States. Having these numbers in mind and the price point set at $500, we have calculated that over 5 years, StarGait will result in $1.7 million in revenue. For next steps, StarGait should particularly focus on further research and development, commercialization, and conducting clinical trials. In the first stage, StarGait should partner with Device Lab. Device Lab is a medical device design company that will help StarGait with furthering hardware and software and developing appropriate user interface for data collection mechanism. After this has been successfully completed, OU Office of Technology Development will file for a patent. At about the same time, clinical trials should start, which is necessary for the FDA certification. FDA certification will be a pathway for the StarGait to be licensed and eventually manufactured and ultimately distributed to the end users. It's been truly honorable experience to be involved in such a project this semester. We're thankful for all the individuals that have gave us an insight in what this disease is and what it isn't, especially Parkinson's Support Group and people that suffer from this condition. The team truly hopes that it's going to continue involvement with this project. Thank you very much. Now we'll open the floor for questions.
What does this device tell me? Does it help me? What's the data tell me?
Yeah, so you're asking about what the data would do to help you if you were a Parkinson patient. The data will help you to understand when your episodes are occurring and how long the duration is, so maybe the severity. This will help you be able to compare when your episodes are happening with your medication schedule, so maybe you can adjust your medication schedule, or if you're having them at a really high activity part of the day, you can start adjusting your day so that you maybe spread your activity out throughout the day, or you can go to your physical therapist and get better techniques on when to overcome these episodes.
Yes. Yeah, what was your question?
So what's the 1% growth rate?
So 1% growth rate reflects the annual incidence of Parkinson's disease in the United States.
Okay, so it's overall population.
That's correct.
What would it take to see a growth rate higher than just the general population?
The team believes that focusing on the market that was presented, the expansion market, would result in a higher growth rate, other than just focusing especially on Parkinson's disease.
We have time for one more question.
What's the production cost of the device?
The production cost of the device is $100 per unit. We factored in labor costs as well as cost of materials.